October 19th, 2017. Pan-STARRS Telescope, Maui, Hawaii. Rob Weirick, a postdoctoral researcher, reviews the night's observations. One object stands out. It's moving fast, 87 kilometers per second relative to the Sun. Its trajectory is hyperbolic, not bound to the solar system, not orbiting anything. For the first time in recorded history, we've detected an object from another star system passing through ours. The Hawaiian name, Oumuamua, roughly translates to scout or messenger arriving from the distant past. The first known interstellar visitor. It came from the direction of Vega, traveled through interstellar space for millions of years, passed within 24 million kilometers of the Sun, close enough for telescopes to study it, then left. Fast. As it departed, something strange happened. It accelerated. Not from gravity, we'd accounted for that. Not from rocket engines, obviously. It was being pushed by something. One of Harvard's top astronomers looked at the data and said, "This might be artificial technology." The scientific community said, "Absolutely not. There's a natural explanation." 7 years later, we still don't know what it was. Let's investigate. Pan-STARRS 1 telescope searches for near-Earth asteroids, potentially hazardous objects that might threaten Earth. Automated systems flag moving objects. Humans review. October 19th, 2017. Object C/2017 U1 appears in the data. Initial orbital calculations. Strange. Eccentricity, greater than 1.0. In orbital mechanics, eccentricity measures how elliptical an orbit is. E equals 0, perfect circle. E less than 1, ellipse, bound orbit. E equals 1, parabola, escape trajectory. E greater than 1, hyperbola, unbound, came from elsewhere, won't return. Oumuamua's eccentricity, approximately 1.2. This object isn't orbiting the Sun, it's passing through. Further analysis confirms interstellar origin, incoming velocity relative to local standard of rest, approximately 26 kilometers per second. That's the average motion of stars in our galactic neighborhood. Oumuamua entered our solar system moving at roughly the same speed as nearby stars. Strong evidence it came from interstellar space, not from within our solar system. Path. Entered from direction of constellation Lyra, Vega region. Approached from above the plane of the solar system. Made closest approach to Sun on September 9th, 2017, before discovery. Passed Earth's orbit, October 14th. Detected October 19th, already leaving. Exited downward through solar system plane. We discovered it on its way out. Never got a close look. First thought, asteroid. Rocky body from another star system, but no asteroids have hyperbolic orbits. Need new designation. October 25th, 2017. Reclassified as 1I/2017 U. 1. 1I equals first interstellar object. Then, maybe it's a comet. Comets are icy bodies. When heated by the Sun, surface ice sublimates, turns directly to gas, creating visible coma, cloud, and tail. This outgassing creates non-gravitational acceleration, the rocket effect, as gas jets push the comet. Observation. No coma detected, no tail, no outgassing visible. If it's a comet, it's not behaving like one. October 2017. Scientists realize they need better naming conventions for interstellar objects. Hawaiian name chosen. Oumuamua. Pronunciation. Oumuamua. Meaning, a messenger from afar arriving first, or scout. By November 2017, Oumuamua was too faint for further observation. Distance, too far, reflecting too little sunlight. Telescopes lost it. Whatever it was, it's gone. Data collected, limited. Questions, many. Before Oumuamua, every natural object we'd observed came from within our solar system. Meteorites, fragments of asteroids or comets, orbiting the Sun, occasionally hitting Earth. Asteroids, rocky remnants from solar system formation, orbiting Sun. Comets, icy bodies from Kuiper Belt or Oort cloud, orbiting Sun, even if on very long-period orbits. Oumuamua came from outside, formed around another star, ejected somehow, drifted through interstellar space for millions of years, then passed through our solar system by chance. This proved interstellar objects exist. They pass through. We can detect them. If we detected one in our first serious survey, how many are out there? Estimates. At any given time, there might be several interstellar objects passing through the inner solar system. Most go undetected. Too small, too fast, wrong angle. Oumuamua, lucky detection. Right place, right time, bright enough. But it raised a question. Is this normal or special? Astronomers tracked Oumuamua's brightness over several nights. Result? Brightness varied dramatically, by a factor of 10 or more. Interpretation: Oumuamua is tumbling, rotating end over end. When the long axis faces us, we see more surface area, brighter. When edge on, less area, fainter. The brightness variation tells us the object's axial ratio, how elongated it is. Estimated ratio, at least 10 to 1, possibly higher. 10 times longer than it is wide. Problem: no known asteroid or comet in our solar system is that elongated. Two possible shapes fit the data. 1. Cigar-shaped. Highly elongated prolate spheroid, like a cucumber. 2. Pancake-shaped. Oblate spheroid, like a disc or pancake. Both extremely unusual. Estimated size: roughly 100 to 400 meters in longest dimension, 35 to 40 meters in shortest. Color: reddish, similar to outer solar system objects, Kuiper Belt. Reflectivity, albedo, relatively high for an asteroid, approximately 0.1. Engineering question: how does such an elongated natural object form and hold together? High rotation rate plus extreme elongation equals structural stress. Most rocky bodies this shape would break apart, unless it's very strong, or not rotating fast, or not made of rock. As Oumuamua left the solar system, astronomers continued tracking its position. Expected: path determined purely by gravity, sun, planets. Observed: deviation from predicted trajectory. Oumuamua was accelerating away from the sun at a rate gravity couldn't explain. Magnitude: Small but measurable. Roughly 5 times 10 to the power of -6 meters per second squared. About 0.00005% of Earth's surface gravity, but detectable with precision measurements. Direction: radially outward from Sun, away from the gravitational pull. Interpretation: non-gravitational force acting on the object. Standard explanation for non-gravitational acceleration: outgassing. Comets do this. Sun heats ice. Ice sublimates. Gas jets push comet. Rocket effect. But no outgassing detected. Astronomers looked for water vapor, carbon monoxide, carbon dioxide, dust coma. Result: nothing. No detectable gas. No dust cloud. Counterargument: maybe outgassing was too weak to detect. At Oumuamua's distance, telescopes could have detected substantial outgassing. They saw nothing. If it's a comet outgassing enough to cause measured acceleration, we should have seen it. We didn't. Confirmed facts about Oumuamua. Interstellar origin, first confirmed. Hyperbolic trajectory, passing through, not orbiting. Highly elongated shape, 10:1 ratio or more. Tumbling motion, chaotic rotation. Reddish color, organic rich surface. Non-gravitational acceleration, departing solar system. No detected outgassing. No visible coma or tail. Unknowns. Composition: rock, ice, metal, other. Internal structure: solid, porous, hollow. Formation mechanism: how did it get that shape? Acceleration cause: what pushed it? Origin: from which star system? We have two contradictory observations. 1. Non-gravitational acceleration, typical of comets. 2. No outgassing detected, typical of asteroids. Comets accelerate, asteroids don't. Oumuamua accelerated, but showed no comet-like activity. Natural explanation camp: it's a comet with unusual properties we don't yet understand. Artificial hypothesis camp: it might be technological, a probe or debris from another civilization. This is where Avi Loeb enters. Avi Loeb, chair of Harvard Astronomy Department at the time. Renowned theoretical astrophysicist. His proposal? Oumuamua might be a light sail. Light sails: thin reflective sheets pushed by photons from stars. How they work. Photons have momentum. When reflecting off a surface, they transfer momentum, creating thrust. Human technology. We've built light sails. Icaros, Light Sail 2. Concept proven. Loeb's hypothesis. Oumuamua could be a thin, flat object, explaining 1. Extreme elongation. If pancake-shaped, disk, the 10:1 ratio is length to thickness, not length to width. 2. Non-gravitational acceleration. Solar radiation pressure pushing the thin sail. 3. No outgassing. Because it's not a comet, it's artificial. For radiation pressure to cause observed acceleration, Oumuamua must have very high surface area to mass ratio. If it's a solid rock with observed dimensions, radiation pressure too weak. But if it's a thin sheet, less than 1 millimeter thick, radiation pressure could explain the acceleration. Loeb's calculation. If Oumuamua is a sail approximately 100 to 200 meters across and less than 1 millimeter thick, solar radiation pressure produces the observed acceleration. Material. would need to withstand interstellar journey, reflective, strong enough to not tear. Loeb's argument. This is within technological possibility. We could build something similar. Loeb's nuance. He doesn't claim Oumuamua is an active alien spacecraft. His actual hypothesis: it could be technological debris. Analogy. Like humanity's defunct satellites, we launch probes. They eventually become non-functional, drift through space. If technological civilizations exist in the galaxy, they likely produced artifacts. Some become space junk. Over billions of years, how much technological debris might be drifting through the galaxy? Loeb's estimate. Statistically, not implausible that some fraction of interstellar objects are artificial. Oumuamua. Possibly a defunct light sail from another civilization, launched millions of years ago, purpose unknown, now just drifting. Scientific community reaction. Overwhelmingly skeptical. Criticisms. 1. Extraordinary claims require extraordinary evidence. Sagan standard. Alien technology is an extraordinary claim. The evidence, anomalous acceleration, doesn't meet that threshold. 2. Natural explanations not exhausted. Science prefers simpler, natural explanations before invoking alien technology. 3rd, Occam's razor. Simpler explanation, unusual comet, preferred over complex one, alien artifact. 4. Lack of additional evidence. No signals detected, no unusual chemical signatures, nothing beyond the acceleration anomaly. Media reaction. Harvard astronomer says Oumuamua could be alien spacecraft. Loeb's nuanced hypothesis simplified to clickbait. Public fascination. Massive. Scientific reputation. Damaged. Some colleagues distanced themselves. Why did scientists push back so hard? Not because they're closed-minded about aliens. Because the hypothesis doesn't meet scientific standards yet. Bayesian reasoning. Prior probability of unusual comet, high. We know comets exist. We know they can have unusual properties. Prior probability of alien artifact, very low. We have 0 confirmed examples. Evidence needed. To shift from high probability natural explanation to low probability artificial explanation requires compelling, unambiguous evidence. Oumuamua's anomalies. Interesting. Not compelling enough to override priors. Loeb's response to criticism. Put your money where your mouth is. 2021, founded the Galileo Project, scientific search for evidence of extraterrestrial technological artifacts. Goal? Not to prove Oumuamua was artificial, to systematically search for interstellar objects and analyze them properly. Strategy. Develop dedicated survey telescopes. Create rapid response protocols for future Oumuamua-like detections. Analyze interstellar objects with no prior assumptions. Search for technological signatures, unusual materials, geometries, signals. Philosophy. If alien technology exists, we won't find it by assuming it doesn't. We need to look properly. (2020) Hypothesis. Seligman and Laughlin. Oumuamua is a hydrogen iceberg. Concept. In cold interstellar clouds, hydrogen can freeze into solid ice. Key insight. Hydrogen ice sublimates, turns to gas easily when warmed. But hydrogen gas is invisible. No spectral lines we'd easily detect at Oumuamua's distance. Proposed mechanism. Oumuamua formed as a hydrogen iceberg in cold interstellar cloud. Entered solar system. Solar heating sublimated hydrogen from surface. Hydrogen outgassing pushed object, non-gravitational acceleration. But hydrogen gas invisible to our telescopes. Advantages. Explains acceleration without visible outgassing. Problems. Hydrogen ice is fragile. Would Oumuamua survive interstellar journey intact? Hydrogen ice forms only in very specific conditions. Giant molecular clouds, specific temperatures. Never observed hydrogen icebergs in our solar system. Would they exist? 2021. Hypothesis. Jackson and Desch. Oumuamua is nitrogen ice, like Pluto's surface. Inspiration. Pluto has large regions of nitrogen ice, Sputnik Planitia. Scenario. Oumuamua was once part of Pluto-like exoplanet, icy world in another star system. Impact ejected chunk of nitrogen ice. Piece drifted through space, entered our solar system. Nitrogen ice sublimated when heated, causing acceleration. Nitrogen gas difficult to detect spectroscopically. Advantages. Nitrogen ice exists, we've seen it on Pluto. Sublimation rate matches observed acceleration. Explains lack of visible coma, nitrogen less visible than water. Problems. Requires specific impact scenario to eject Oumuamua-sized chunk. Nitrogen ice would erode over interstellar journey. Cosmic ray bombardment, collisions. Shape still unusual even for nitrogen ice. Occam's razor. When multiple explanations fit the data, prefer the simplest. Simplest doesn't mean easiest to understand. It means fewest unsupported assumptions. Hydrogen iceberg hypothesis assumes hydrogen ice can form in interstellar clouds. Plausible. It can survive interstellar journey. Questionable. It entered our solar system. Rare but possible. Nitrogen ice hypothesis assumes exoplanet with nitrogen ice existed. Plausible. Pluto analog. Impact ejected fragment. Plausible. We see planetary collisions. It entered our solar system. Rare but possible. Alien artifact hypothesis assumes extraterrestrial technological civilization exists. No confirmed examples. They built light sails. Plausible if they exist. One happened to pass through our solar system. Extremely rare even if they exist. We detected it during brief passage. Lucky timing. Scientific consensus. Natural explanations have fewer unsupported assumptions. Here's the honest truth. We don't fully understand Oumuamua. None of the natural explanations are perfect. All have issues. But we don't know doesn't default to, therefore, aliens. History lesson. 1967. Jocelyn Bell discovers pulsars, rapidly pulsing radio sources. Initial thought, LGM, little green men, alien signals. Reality, rotating neutron stars, natural phenomenon we hadn't seen before. 2007, fast radio bursts discovered, brief, intense radio pulses from deep space. Speculation, alien communication. Reality, still being studied, but leading theories are natural. Magnetars, colliding neutron stars. Pattern, when we see something we don't understand, first instinct might be alien. But we've never found aliens. We've always found new natural phenomena. Oumuamua might be the same. Natural object behaving in ways we haven't seen before because it's the first interstellar object we've studied. What evidence would convince scientists Oumuamua was artificial? 1. Signal detection. Radio, laser, or other communication from object. 2. Trajectory changes. Powered maneuvers inconsistent with natural forces. 3. Structural details. If we'd gotten close-up images showing geometric shapes, joints, clearly manufactured components. 4. Chemical composition. Materials not found in nature. Pure metals, synthetic compounds, isotope ratios impossible naturally. 5. Multiple examples. If many interstellar objects showed similar anomalies, artifact hypothesis gains weight. What we had: distant light curve measurements, trajectory data, no close-up images, no spectroscopy detailed enough for composition, no signals. Not enough. Problem: we have exactly one well-observed interstellar object. Sample size 1. Can't determine if Oumuamua is typical or anomalous for interstellar objects. Maybe all interstellar objects accelerate strangely. Maybe none do, and Oumuamua is unique. Mead: more detections, more data, more comparisons. Good news. We've since detected second interstellar object, 2I/Borisov, 2019. It behaved like a normal comet. So Oumuamua is unusual compared to at least one other interstellar object. Silver lining: Oumuamua changed how we search. Before 2017, didn't prioritize searching for interstellar objects. After, multiple survey projects funded. Vera Rubin Observatory, Chile, expected to detect dozens of Oumuamua-sized interstellar objects per year. Goal: catch them earlier, on approach, not departure. Get better data, better spectra, better images. Next Oumuamua will be ready. Dream: intercept an interstellar object. Send spacecraft for close-up study. Problem: they move fast, limited warning, hard to catch. Proposals exist. Project Lyra, intercepting Oumuamua. Other concepts for future objects. Challenges: need to detect object early, years in advance ideally. Launch window narrow. High delta V, change in velocity required. Mission cost: hundreds of millions to billions. But if we detect another Oumuamua-like anomaly, there might be political will to fund intercept mission. Confirming alien artifact. Worth any cost. Fermi paradox. If intelligent life is common in the galaxy, where are they? Why no contact? Drake equation estimates potentially thousands to millions of technological civilizations in Milky Way. Observable evidence: 0 confirmed. Possible explanations: rare Earth. We're alone, or nearly so. Great filter: something prevents civilizations from lasting long. Zoo hypothesis: they're here, but avoiding contact. Transcension: advanced civilizations migrate to different substrates, simulation, other dimensions. Self-destruction: civilizations destroy themselves before interstellar expansion. Loeb's perspective: even if civilizations are rare or short-lived, artifacts might persist. If technological civilizations existed in the galaxy over billions of years, they might have produced artifacts. Defunct probes, space junk, megastructures, partial or complete. Industrial byproducts. Question: what fraction of interstellar objects might be technological debris? Loeb argues, even 0.01% would mean dozens to hundreds of artifacts in our solar system's vicinity over time. Oumuamua, maybe one such artifact, or maybe not. Point: we should look. Assuming all interstellar objects are natural might cause us to miss evidence. The core tension. How do we balance open-mindedness with skepticism? Two ways to be wrong. 1. Dismissing real evidence. If Oumuamua actually was artificial and we ignored it because aliens are improbable, we missed first contact. 2. Believing insufficient evidence. If we claim Oumuamua was artificial without proper evidence, we damage scientific credibility and mislead the public. Scientific approach. Proportion belief to evidence. Update as new data arrives. Current evidence for Oumuamua being artificial, insufficient. Current evidence for Oumuamua being unusual natural object, strong but not conclusive. Verdict: remain curious. Keep investigating. Don't jump to conclusions. Oumuamua's legacy. 1. Proof interstellar objects exist and pass through, no longer theoretical. 2. Improved detection capabilities, new surveys that are protocols. 3. Public engagement. Millions now aware we can detect interstellar visitors. 4. Scientific debate. Forced conversation about how we'd recognize alien artifacts if they exist. 5. The Galileo Project. Dedicated search effort for technological signatures. Even if Oumuamua was natural, it changed how we watch the sky. October 2017. For the first time, we detected an object from another star system. Oumuamua, the scout, the messenger. It was strange. Shaped like nothing we'd seen, 10:1 elongation. Accelerated without visible cause, no outgassing detected. Tumbled chaotically through space. Left before we could study it properly. Was it natural? Probably. Most scientists think so. Was it artificial? Can't rule it out completely. Don't have enough data. 7 years later, we still don't know what it was. And that's okay. Science doesn't always provide immediate answers. Sometimes it provides better questions. The questions Oumuamua left us. How do interstellar objects form? What causes non-gravitational acceleration without visible outgassing? How would we recognize alien technology if we saw it? What's the right balance between skepticism and open-mindedness? More interstellar visitors are coming. Dozens per year, perhaps, thanks to Vera Rubin Observatory. Maybe the next one will be clearly natural, a normal comet, removing all mystery. Maybe the next one will be even stranger, forcing us to reconsider what's possible. Maybe one will be unambiguously artificial, changing everything we know about our place in the universe. Oumuamua is gone, traveling through interstellar space at 26 kilometers per second. In 20,000 years, it'll pass near another star system. Maybe someone there will detect it. Wonder what it is. Argue about its origin. This is Cosmic Canvas, where we investigate the universe's mysteries, even when those mysteries remain unsolved. Until next time, keep watching the sky. The next visitor might arrive at any moment.